lecturer Dr. Adam Wong. Today we are going to present about offset quadrature phase shift keying or QPSK. So the first we like to introduce ourselves. My name Hakim Mirza Mamanafia, and my three other friends, Mahfaz Sabila, Wang Liyun and Nur Syafiqah Nabila, will present about OPQSK. So the objective of the OPQSK is to understand the application of OQPSK. Next is to compare between QPSK and investigate the differences of QPSK. Okay, so the definition of OQPSK is, it is called staggered quadrature phase shift keying, SQPSK. OQPSK limits the phase jumps that occur at symbol boundaries to no more than 90 degrees and reduces the effect on the amplitude of the signal due to any low pass filtering. The advantage of OQPSK is the limited phase shift that must be imparted during modulation, and the disadvantage of OQPSK is that it change in the output occur at twice the data rate.
Okay, this is comparison between OQPSK and QPSK based on this waveform. For OQPSK is modified form of QPSK, where the bit on the I and Q channel are offset in phase from each other by 1/2 of a bit time. Okay, for QPSK, because changes in the I channel occur at the midpoint of the Q channel bits, and vice versa, there is never more than a single bit change in the D bit. Okay, this is the comparison between OQPSK and QPSK. For OQPSK, phase changes of plus minus 90 exist. Less demand of linear amplifier, efficient non-linear amplifier can be employed, and they do not cause much spectral regrowth, as one of the bit changes the phase at a time and occur twice during the symbol period with half the intensity of QPSK. Amplitude variation are of the order of 3 dB. For QPSK, phase changes of plus minus 90 and plus minus 180 degrees. Requirement of linear amplifier as non-linear amplifier causes spectral regrowth because of abrupt plus minus 180 degree transition of the both bit change at the phase at the same time. For amplitude variation are of the order of 30 dB.
So now I will talk about the application. There are 6 applications for OQPSK. The first one is satellite transmission of MPEG-2 video. The second one is cable modems, and then video conferencing, cellular phone system, coherent OQPSK demodulator, and other forms of digital communication over an RF carrier.
Okay, now I want to explain about coherent OQPSK demodulators. The implementation shown in figure corresponds to the multiplexing of 2 independent data streams through orthogonal carriers, as in the case of the conventional QPSK modulation. The OQPSK demodulator is very similar to the QPSK demodulator, the only difference being the fact that the 2 BPSK detectors operate dB seconds delay from one another. Before parallel to series conversion, the estimate data stream must be aligned in the time by using a delay block placed in the arm opposite to the one where the delay was inserted at the modulator. Due to obvious reason, the power spectral density and error probability for the OQPSK modulation are the same as the derived for the conventional QPSK modulation. Thank you.